Why do ice and water behave so differently? Ice floats while rocks sink. This small quirk is vital for our planet. It keeps winter lakes alive and influences our climate. Let's break down the key concept, buoyancy. Objects float when the weight of the water they displace equals their own weight. Buoyancy explains why some things stay afloat. Now, what determines if something floats or sinks? Its density. Density is the mass of an object divided by its volume. Most substances become denser when they freeze, but water is unique. A water molecule contains 2 hydrogen atoms and 1 oxygen atom. This structure creates tiny electric charges, making it polar. These charges lead to hydrogen bonds between adjacent molecules. These bonds form, break, and reform in a constant movement. As water cools, the molecules slow down and become more ordered. They start lining up into a crystal pattern. This is where ice's structure becomes crucial. Ice forms a hexagonal lattice with open spaces, like a delicate snowflake. With the same mass occupying more space, ice becomes less dense. This is the key reason ice floats on water. When water freezes, it expands by about 9%. This small change has significant effects. Less dense ice floats on denser liquid water. So ice rises, supported by the liquid below. Here's a fascinating detail. Liquid water is densest at about 4 degrees Celsius. When it gets colder, the surface water cools and sinks until it reaches this temperature. Once it does, it stops sinking, allowing the top to freeze into an insulating layer. This means life can continue thriving under the ice. Lakes don't freeze solid, they shelter life below the surface. Icebergs float for the same reason too. About 1/10 of an iceberg is visible above water. Salt water is denser and freezes at lower temperatures, but still follows this principle. Ice remains buoyant on salt water due to its airy structure. It's important to remember, freezing expansion can crack rocks and even pop bottles in your freezer. To sum it up, hydrogen bonds create an open lattice structure, lowering density, allowing ice to float. This molecular dance brings about planet-sized effects. Isn't that fascinating? If you enjoyed this understanding, like and subscribe for more Byte-Size Science.